Okay, to start with, I want to start with just reviewing what piecewise means before we start graphing. Okay, to start off with, um, what goes in here differs a lot. Sometimes there's just a big space. Sometimes there's like a semicolon or a colon. Sometimes there's the word if. Sometimes there's the word when. It differs a lot. Most of the time, I just leave a big space. But I just want you guys to realize that it can be a lot of different things. Just anything to separate the function and the inequality. So over here we have the actual function. And over here we have when that function occurs. So whenever we do this, we always start over here in this section. So wherever I want to do A and I want to find f of 4, I start in the right-hand section. With that 4, when does that 4 meet those criteria? It'd be down here. 4 is greater than or equal to 2. So 4 is not less than negative 3. 4 is not in between negative 3 and 2. But 4 is greater than 2. So 4 meets this criteria. So 4 is greater than or equal to 2. That's the one that works. So what that tells us is that we're going to use this function here. So we can only use one of the functions at a time. We can't use all three. So that would be our solution. So with a piecewise, you never plug a number into all three of them. You only ever use one. Which 4? This one? So f of 4, so whatever goes inside here is what replaces the x. So technically it should have replaced it up here. I just wanted to write this to make sure you understood where that came from. So if I did f of negative 4, which one would I plug that one into? Yeah, that one will go into the 2x minus 1. because negative 4 is less than or equal to negative 3. Okay, one thing I want to make sure of for whenever we're doing graphing, what is f of 0? Just 4. So whenever I put in 0, 0 meets this criteria here, right? What this is saying is that for any x that meets this criteria, our y value just equals 4. So you don't have to do any work for that. That usually confuses people a little bit. But for that section, it's just y equals 4. For any number in here, it equals 4. Because that's just what it says. Yeah. Just because there's no x there. So if I did f of negative 1, that would be 4. What's f of negative 3? Because that's in 2 of the groups, right? No, it's only in one group. Which group? The top one, because the top one has the equal sign, the second one doesn't. Sorry. Right? So f of negative 3 only belongs to the top group because the top group has the equal sign, the bottom group has a strictly less than sign. So it'd be the same thing with 2. 2 would be, well, 2 is going to be 4 either way, isn't it? But whenever you did 4, you would plug it into the third equation, right? Yeah. Sorry, yes. I was going too fast. Sorry. There you go. All right, so is that part okay? Because graphing is a lot easier if you understand that part of it. Okay, so we're going to move on to graphing. We're going to start with an easy one and we'll work our way up to harder ones. If you need graph paper, go ahead. Shouldn't put my arrow there. I should have made this go on over here. Okay, I'm going to try to give you one way to do this. There are multiple ways of doing this. I'm going to give you the way I think that is easiest to start with. If you have learned to do this a different way, or you think you know a better way of doing this and you choose to try to do this differently, just realize I am not going to count you wrong on a test or something for not doing this the way that I showed you. I'm interested in you getting to the correct solution, not doing it the way that I do it. All right. I usually suggest starting here, doing this first. Take your graph and split it apart, because technically what we have here is we have two graphs. So what I'm going to do is I'm going to split my graph at -2. What this tells me is whenever x is less than -2, so on the left-hand side of this, what I'm going to be graphing is y equals x plus 1. On the right-hand side of this, I'm going to be graphing y equals 2x minus 1. Yeah. Since this tells me that this is where my split is, at -2. So I'm literally splitting my graph there. So my top equation has to stay on one side of the line, my bottom equation has to stay on the other side of my line. So I'm just making a physical representation of that so that I can see it, so I don't cross my lines. Okay, so on this side, I need to graph this. Now, we're used to, starting at my y-intercept and using my slope. The problem is, my y-intercept is not on this side of that dotted line. So, there are two ways you could do this. One way, if you're very careful, you can go ahead and use your y-intercept and use your slope and work backwards until you get onto this side of the dotted line. Or you can just simply plot points on this side of the dotted line. Either way, I don't care, as long as your graph only shows up on this side of the dotted line. So I'll do it both ways for you. On this one, I'll go ahead and plot points. On the next one, I'll use slope and get it over there. So on this one, what I'm going to do is, let's see, I'm going to plug in, I'm going to plug in -2. Now, don't make any points until I show you. Now, -2, -1. I cannot put a dot there because this one isn't actually included on this line, right? Because I have a less than sign. So what I can do is I can use an open circle. -3, -2 is fine. So there's my line. So the side that is not included on that line, the side without the equal sign, what we do is we use an open circle where it hits that dotted line. just like on a number line, whenever you used to use dots and circles, it's the same idea here. We're just doing it in 2 dimensions instead of 1 dimension.
So what does the open circle mean again?
It means that we cannot be equal to the value at -2 because we don't have the equal sign here.
Okay, but so the solid dot means equal to?
Yeah.
Mr. Gillette?
Yeah.
We use solid dots for representation of greater than or less than and then equal to.
Yeah, so whenever we do the second one down here, we use our solid dot. Now, on this one, I can go ahead and use my slope. So up 2 over 1. Now, where my line hits that dotted line here, I want to use a solid dot because here we have that equal sign. So because I have the equal sign on this one, I want to use a solid dot. Because I don't have it on this one, I want to use an open dot. Now, the only place you have to worry about that is right here on the dotted line. Okay, did I make it simple enough or confusing? Do a couple more? Yeah.
So basically it's 2 random points. I'm going to both equations and then graph them.
Yeah.
But if it's on the line and it's not an equal sign, it's a bigger circle.
Yep. And the dotted line is the only place you have to worry about it.
But if it's like, if it does have an equal sign, it's a solid dot?
Yep.
Okay, cool.
Valerie?
Yes.
Okay. Okay, so let's do a couple more of them because I'm going to make them a little bit harder each time. Oh, I forgot to put my inequalities in. That would help, wouldn't it? Oops. Okay, so my suggestion would be to start off by separating your graph. Because again, since this is a function, we can't have more than one line per area. Because once you have more than one line per area, you no longer have a function. Okay, so whenever I'm less than, so each of these dotted lines just represent these numbers that are here. So I have a dotted line at -2 and a dotted line at 0. Okay, whenever I'm less than -2, I'm going to graph this line. In between -2 and 0, I'm going to graph this line. And then to the right of 0, I'm going to graph this line. Alright, so on that first one, let me show you how to use slope instead of just plotting random points. Alright, so y-intercept for this one is 0, right? So just don't make any marks and use your slope to go backwards until you hit that dotted line. So it would start at 0. My slope is -1, so that means I can go up 1 and to the left 1, right? Normally it's down 1, right 1, so that means I can go up 1, left 1. Up 1, left 1. Once I hit my dotted line, then I can start making points. Now this one, since I don't have an equal sign, this one's going to be a circle. Up 1, left 1. Make a couple more points, and there's my line. So if you want to do your problem that way, that's fine. If you don't want to plot some points. If you feel more comfortable plotting a few points, plot a few points. Just make sure if you're going to use the slope starting from the y-intercept that you don't make any dots until you hit that red line. Okay, y equals 5. That's just a horizontal line at 5, right? This one has both the equal signs, so 1, 2, 3, 4, 5. So I'm going to use dots for this one. So those are always nice to see because those are nice and easy. Okay, right hand side, y equals x plus 2, so I start at 2. This one does not have the equal sign, so I'm going to use an open circle. My slope is 1, so that's up 1 over 1. And I have my graph.
So this one would not be a function?
No, this one's a function.
But I thought you said if you had more than one dotted line.
No. It wouldn't be a function is if you messed up and you made this one go farther and you start drawing your line out here, then it wouldn't be because it went past the vertical line test. That's also the reason why we have to have these open circles here, because if I put a dot here, then it wouldn't pass the vertical line test because I'd have 2 points on this vertical line. So that's why one has to be a closed dot and the other one has to be an open circle. No, we could have some with, 5 splits. That's fine. Okay, I want to do one more with you to show you something else that can happen that tends to confuse people. We okay with that one? Can I move it? All right. Okay, let's see. Let's do a Okay, let's do that one. Okay, so I have dotted lines at -3, -1, 1, and 3, right? I put dotted lines wherever I have numbers over here on this side. So 1, 2, 3, so -3, -1, 1, and 3. So that's a lot of dotted lines.